Hello everyone. I'm really sorry for the delay today. Can you all hear me properly? Yes or no? Please tell. Guys, okay. No, it's not raining. How do you have guys rain? Shiv Shankar, it is not raining right now, but the problems after rains can exist, right? There are some big time technical issues going on, trying very hard to solve it, but just getting stuck. Really sorry, guys. How is everyone? Okay, Samar sir. Vinod, my name is not Samar. My name is Samir, right? Hi, Abid. After so many days, I'm seeing you. Ahrar, how are you? Hello, sir. Shiv Shankar. Fine, sir. Okay. Devankita is also fine. Guys, let's start then. We are already running out of time today, right? Already running out of time. Okay. So, Science Beyond Books Class 4. So, there was this girl called Sudipti. Is she in the chat today? She asked a very interesting question in the last class. Summer, sir. Taste my Samyal says Summer, sir. Okay. Okay, if you want to call me Summer, it's fine. I'll rather be called Summer. Sudipti, are you there in chat? Varsha Lal, my name is also Samir. Okay, that's very nice. Good afternoon, Yashaswini. Good afternoon, Sridhar. Good afternoon, Hemant. After so many days. So you can call me Siddharth. Okay, Shiv Shankar. Because Shiv Shankar is the first name I see, so I call that. Right. Hi, Anand sir. Hello, Kovida. Swami, how are you? I'm good. Okay. Manaswi Singh, are you Sudipti? Who asked the Moonlight question. Hi Rohit, hi 3T Vlogs, are you rocking? Not very sure. Okay guys, let's start the class, okay? So quickly about Practically, most of you guys are already existing. Practically is an e-learning platform, AR/VR content. All of you have the app, all of you know about this. We'll go to the next slide. Summer workshops, all of you are super familiar with it. Great, we'll go to the next slide. Gifts and rewards, something that might interest you. Good questions get rewarded. You will be put on the leaderboard. So ask good questions in the chat. Then you have referral awards. The one who refers the most gets a gift hamper. Best projects. Today I'm going to announce the project for Science Beyond Books Junior course. So keep an eye out for it and try to do it as nicely as you can, right? And you can win this award. This is very easy to win because I know most of you lazy people won't even submit the project. So all of you who submit have a very high chance of winning. But I want you all to submit. Now, the condition here is you have to have some attendance, 70% is required. Just try to attend the classes because without that, you can't even do the project. So that's kind of given. And there's one award for 100% attendance, right? So if you attend all the classes, you get the award, right? Special gift hamper. Great. Great then. Today's class is all about eclipses, Earth's magnetism, and aurora borealis. How to submit? I will tell Bhavesh. I will tell when I'm talking about the project. I will explain how to submit. Okay? Okay, I will explain Vimochana, no issues. Sir, video is blur. Eternal problem. The video is blur. What do we do about it? Can anyone tell me in the chat, what do we do if the video is blur? Who will explain in the chat, what do we do? Yeah, electricity topic was coming, Himanshi, but the thing is that eclipses was not over in the last class and someone asked about aurora borealis. So I thought I'll take magnetism first and then I'll take electricity. Okay, so I have made that switch voluntarily by my choice, right? Right before the class, I made the switch. So yeah. Okay, people are telling whoever asked the question, video quality is bad. Your friends are already telling you what to do. Okay, increase the video quality to 720p or 1080p. So the video is not blur. I think you wanted to write blur in the hurry of typing. You wrote blur. It's okay. Bhaven asked that doubt. Kya? Moonlight wala. Okay. Achha, you asked a doubt for aurora borealis. Okay. So today is your class, Bhaven. Pay attention. Okay, guys. Okay. Okay, guys. Let's start the class. The class is for 1 hour. It might end by 4:15. Today we started a slightly late. I'll try to finish it by 4:15. I'm really sorry for the delay due to technicalities. So, Sudipti, I forgot the name that comes on the chat, asked me this question. And then she repeated in the maths class yesterday. And I personally feel it's a very good question. Okay. So the question is, why does moonlight appear yellow when why does moonlight appear white when sunlight appears yellow? Okay. So in the last class, in the scattering part, I clearly explained it to you why sky appears blue and why setting sun appears yellow, right? Like why sun appears yellow whenever we look at it. And then why does it appear red? That was the refraction part that we didn't really cover. But in the scattering class, I basically talked about why sun appears, why sunlight appears yellow. Okay. Okay. Now tell me, does anyone know why does moon appear white? Sir, please say slowly. I'm speaking slowly. Sagar, I'm trying to rush it. That's why I'm speaking fast. The sun rays reflect the moon. That's why. The sun rays reflect the moon. That's not the answer. Sir, I know the answer. Okay, Bhavin, tell me the answer then. Sir, distance. Shravan says distance. Anju, sir, I know. Tell me the answer, guys. Whoever knows, why does moonlight appear white when sunlight appears yellow? If the atmosphere on our earth is exactly the same, nothing changed, what happened? Scattering of light. Samyal, that's the thing, right? White light gets scattered into blue color and then we see the sun as yellow because yellow, orange, red scatter the least. Correct? That's what we talked about in the next class. But the question is, because of the intensity, Anirudh is telling. Okay, I'll repeat the question. The question is, moon is also throwing sunlight at us, right? Sunlight is going to the moon, getting reflected from the moon and coming to us. It's still white light, just like sunlight is white. Moonlight is also white. So our atmosphere should do the same thing, right? It should do the same thing. It should scatter the blue light and the sun should appear yellow or red. But that's not exactly the case. That's not exactly the case. So someone is saying intensity. That's what I told in the last class. That's the explanation I gave. But it is only partially correct. So intensity is true. Because of the sun's low intensity, we see it white. That is the correct answer. But that is only half the answer. The remaining half is not, because the moon is grey. Okay, ghost technology, sun is completely white because sun gives out white light, right? But we still see sun as yellow or red depending on the time of the day. Correct? Yeah, whoever is writing because of the moon's color, that's the problem we are facing, right? Because sun is giving us white light. So for us, sun should be white, but sun is yellow because of scattering that our atmosphere is doing. Just like that, if moon is white, then sunlight coming from it is also white, right? Basically. And the white light should get scattered by our atmosphere, right? Satvik is writing something very random in the middle of an important conversation, which is not good. Satvik will talk about wormholes later. Because moon is white. Sir, because all the colors of the sun fall on the moon and the light mixes on the moon and creates white color. Because all the colors of the sun falls on the moon and the light mixes on moon and creates white color. It is white color, Bhavin. White light falls on the moon, moon sends back white light to earth. But our earth's atmosphere should carry out scattering. That's exactly the question Sudipti was asking. Correct? Sir, the moon is reflecting less light. That's partially correct, Shravan. That's not completely correct. Moon is cold, sun is hot. Not really true. Moon is burning. Srinivas is telling moon is burning. Sorry, sun is burning. Srinivas is telling sun is burning. No. Sun is not burning like how things burn on Earth. Sun is having a completely different burning mechanism going on. It has something called nuclear fusion. Satvik, don't ask me about wormholes again and again. It's distracting. Okay, guys. So let me explain it to you why. Saroj Sahu, sir, what is the loss of profit of eclipse? I remember you asked it in the last class. We will talk about it, Saroj. So, moon is white. All of you can see this. All of you can agree with me that moon looks white. A slightly yellowish sometimes depending on how intense the light is. Sometimes when the light is very intense, like on full moon days and all, it appears slightly yellow, but hardly. Moon appears more or less white. Correct? Okay. So we all agree that moon appears white and sun doesn't appear that white. Okay. So the problem is, why does it happen? If moon is reflecting sunlight back onto earth, if I'm seeing sunlight as yellow, then moonlight should also appear yellow. But moonlight appears white. Now, part of the answer is true that we are receiving less light from the moon. That's why moon appears white. But that doesn't completely explain why the scattering is not taking place. Okay. So now, before I talk about scattering, all of you can see this slide, right? On top of this GIF that is running, you can see I have written a small text, which is Purkinje effect, right? Purkinje effect. Now the thing is, Purkinje effect is, or Purkinje effect. A lot of people call it Purkinje, some people call it Purkinje. It doesn't matter. It's a name. You can call it anything. Now, the interesting part of this effect is that look at the flower. It is actually red in color. The leaves are actually green in color. But as the sun sets, like as the light decreases, right? When we have bright sunlight, we are able to see the red color clearly. We are able to see the dull green color of the leaves clearly. But when we decrease the light, right? When we decrease the light, what is essentially happening? If you can see, we cannot see the red color anymore. Can you guys observe it? We cannot see the red color because our eyes cannot see color when there is low light. So you can already understand where I'm going with this. The color of the moon appears white not because of lack of scattering in the atmosphere, but because of the limitations of our own eyes, right? Because of the limitations of our own eyes. When the light intensity is very, very less, it is very hard for us to see the color. Okay, this is the point I'm going to make at the end of this, at the end of this explanation. But till then, let me explain Purkinje effect properly to you. So here you can see, once again, I'm going to repeat, we have a red colored flower. When we have bright light, it clearly appears red. But when we have low light or when we have evening or nightfall, the red color vanishes. The red color is not actually vanishing. The problem is that when light is less, our eyes are not sensitive to color. Okay? So basically, this entire drama, this entire magical sort of illusion is happening because of rod and cone cells in our eyes. Got it? Rod and cone cells in our eyes. Now, how many of you are familiar with these words? Rod cells and cone cells. Please tell me in the chat. Yes, sir, I'm familiar. No, sir, I'm not familiar. Suvarna, hi. No. Sanitizers are coming again. No, sir. I don't know. No, sir. Me, I know. Yes, not familiar. No. A lot of you are not familiar. Chaudhary Hemant is full on Hindi today. No, sir. No. Okay, guys. So many of you don't know. Some of you might know, right? Some of you might know. Some of you, like most of you don't know. So let me explain what is really going on, guys. Let me explain. It's very interesting. Okay. So you can see that the color of the flower is not changing. Only the light that we are throwing on the flower is changing. But we are perceiving the color in a different way. When the light is less, the red flower is actually appearing quite dark. Like the red color is gone. It's actually appearing like bluish or blackish, basically blackish or bluish, right? This is because of the properties of the two kinds of cells that we have in our eyes. They are called rod cells and cone cells. So let me explain. Now, this is our eye. Okay, my handwriting is not that good. Just assume this is our eye. This is our lens, right? This is our eye lens. All of you are able to see this. This is our eye lens. Now, here at the back of our eye, we have a screen. Okay, we have a screen. Okay, we have a screen. Now, this screen has two types of cells. Okay, this screen has two types of cells, rod cells and cone cells. Pay attention. Rod cells are those types of cells that are designed to detect the intensity of light. So you know those animals that are very, very simple. So we humans are very complex animals, but there are many animals like fishes, many types of birds, even dogs are like, relatively simpler as compared to us. So they predominantly have these rod cells. Now, what do these rod cells do? These rod cells only determine whether there is light or not. Okay, they are very sensitive to the intensity or brightness of light. The other types of cells are cone cells. Cone cells are modified rod cells that, with time, with evolution, as the complex animals grew, these cone cells came into picture. Now, these cone cells are basically modified rod cells that are able to detect color. Okay, so I have in this picture, the cone cells are shown green in color. They're not actually green. They're normal thing only. There is no particular color. But these cone cells are able to detect color. So they are like sensors, just like our phones have sensors. Just like that, these cone cells are color sensors of our eyes. And these rod cells are brightness sensors of our eyes. Got it? Now, cone cells are able to detect three types of colors: red, green, blue. Just like our computer, right? You should all know that our computer screens or our cell phone screens basically have red, green, blue color pixels in them. But by the interplay of these, we are able to see many different kind of colors on our screen. Now, just like that, these cone cells mainly see in red, green and blue colors. Rod cells have no sense of color, have no understanding of color. They are only susceptible to the brightness. Now, what happens is that whenever the intensity of light is high, like when we are in sunlight or when we are sitting inside artificial lights, cone cells are firing. Okay? Cone cells fire only when we have a lot of light, when we have a lot of brightness. Okay? So, rod cells are definitely firing and telling us there is a lot of brightness in the room, and cone cells are accurately telling us color of each and every object that we see in the room. Okay? But when the light is low, only rod cells fire. Cone cells don't fire, because cone cells can fire only when there is a lot of light. This is a fundamental limitation that we humans have, right? We humans have. It is not a natural phenomenon. It is a human limitation that cone cells don't fire when there is low light. So we can't see color when there is low light. Simple. We can only see black and white because rod cells are black and white. They only see how bright something is or how dark something is, right? How black something is, how white something is. So because of this, when low intensity moonlight comes to our planet, right? When low intensity moonlight comes to our planet, it is scattering. Okay? It is not like the atmosphere is not scattering it. It is scattering the blue light. Yellow is coming to us, just like sunlight ka yellow aata hai, in the same fashion. But because the light is very less, it is almost impossible for us to see that yellowness. However, when moon is very bright during full moon time, when it's like, really big, really close to earth, sometimes full moons are close to earth also, right? So when moon is like, super bright, sometimes you can see yellowness in the moon also. But most of the time, moon is white. You should also understand that moon is not always full. Moon is half. Moon is partial also, right? Moon is waxing. Like, sometimes we have moon like this, right? Sometimes we have moon like this, right? Like a part of the moon is only visible, right? So this kind of moon reflects even less light to us. So when light intensity decreases, the ability of our eyes to see colors decreases. That's why we can hardly see color from the moonlight. Are you all able to understand? Shiv Shankar, I'm not reading the chat when I'm explaining, so of course I can't see. I will read. If you type it again, I'm reading the chat right now looking for doubts. Anyone who wants to ask me doubts, please type it in the chat right now. I'm looking. Okay, Saranya is writing something. Sir, the light from the moon is the light reflected from the sun. The sun in space is white. But on the earth, when the light is filtered through the atmosphere, the light appears yellow. Saranya, you are correct about why sunlight appears yellow. But today's question was, why does moonlight not appear yellow? Because moon is also reflecting sun's light only, which is white in color. So moonlight should also appear yellow. But the reason moonlight doesn't appear yellow is not because of scattering. Atmosphere is scattering moonlight also. But it's because of our eyes' inability to see those colors in low brightness. Got it? In low brightness, cone cells don't fire. Cone cells see color. They don't fire when there is low light. Only rod cells fire. Got it? Yes. So, sir, moon has colors. Himanshi is asking. So, sir, moon has colors. Himanshi, actually, moon is like pretty black. Pretty black. But it is not black as such. It is grayish, but it is definitely towards a darker shade. It is basically black and white. One color in the black and white shade. Now, when sunlight falls on it, moon is basically reflecting all that light straight back to earth. Okay, so basically it has white light, and we can say white light has all the colors. So yeah, we can say moonlight has all the colors. Definitely moonlight has all the colors. Sir, why do moon have different colors like red, white, blue, yellow? You're talking about blue moon, red moon, blood moon, all those kind of things. Who asked me this question? Dushyant asked me this question. Dushyant, that happens because of a totally different phenomena. That happens because of refraction. So sometimes what happens, I'm going to explain it. Most of you don't know refraction, I guess. So I'll just explain it in a very brief fashion. This is Earth. This is Earth's atmosphere. Okay, my handwriting is really not nice today. I hope you're able to understand this. This is Earth's atmosphere. This is our little moon over here. Okay, this is our small moon. Now, when sunlight is coming from here, the red light basically bends from the Earth's atmosphere and basically reaches the moon. So basically, it's the red color from the sun which is actually going onto the moon, which we are seeing back again. So it's because of refraction of the atmosphere of the Earth itself. So that's a different thing. We'll talk about it some other time. GNA Naval says, no doubt. Okay. Anirudh is asking, sir, if there are only 3 types of cone cells, how are we able to see all the colors? Anirudh, just like your monitor has only 3 types of pixels, red pixel, blue pixel and green pixel, but you are still able to see all types of colors. Color science is a very complex thing in itself. We'll talk about it some other time. Anju is posting all the phases of the moon. Nice, Anju. Suvarna is posting all the partial moons. Fine. Sir, why is rod cells black and white color? Shekhar, the thing is, rod cells are not black and white in color. Rod cells are normal cells, just like other cells of our body. They are only able to sense brightness and darkness. So you see, when you are only sensing brightness and darkness, you are basically looking in grayscale, right? You can only see something is bright, which appears white to you, or something is dark, which appears black to you. So basically, rod cells have no sense of color, have no idea about color. That's how the evolution has taken place. But complex animals have modified rod cells, which are cone cells, which are susceptible to color. So what is the color of the cell? I am Saranya. Color of the sun. See, Saroj or Saranya. Sun, we only see the color of an object, whatever color it throws back to us. Sun is throwing white light to us, so we see white. Okay, in the afternoon you can see, when you look up, it is mostly white. Sir, can you see the moon yellow using night vision glasses? Night vision is a completely different thing. Night vision basically sees in infrared. That is a completely different thing. It's not even color. It is infrared is a frequency of light which is below red. So we humans can't even see. So whatever you see using night vision is actually not real infrared. It is the camera that is showing something to you because we humans can't see infrared. Chaudhary Hemant, don't ask all these questions. There's no point in asking these questions. Supriya Sudipti, finally. Your doubt is cleared, Supriya. I'm happy. Sir, what if we don't have rod cells? Anant, then that's actually a good question. Then we basically don't have any so any sense of brightness or darkness. We just see feeble colors. Right? We don't actually. Rod cells are the first cells that any organism develops in the chain of evolution. So you see, the first animal that would have got the ability to see, they would have got that ability using rod cells. Okay. So when rod cells kept on going, evolving into complex and complex animals, rod cells kept evolving. They became better and better at their job. Then they started to modify into cone cells. For example, dogs can't see red color at all. They mostly see blue and green because their cone cells are not advanced enough as us humans to see red that clearly. Many times even deers basically get hunted by tigers easily because tigers are orange in color, but deers can't see orange. There was a very good picture. If you want, I can show it in the next class, but I might forget. So you can remind me. Is that deer basically sees green grass, right? It sees green grass just fine. But when a tiger walks by, slowly creeping through the grass, the deer still sees the tiger as green. Many times it can't even see the tiger as orange. It is only us humans who are able to see it as orange and are able to detect the threat early on, but deers can't. So this is the game of cone cells and rod cells. Okay, guys. Manasvi Singh, yes, first animals can't see colors. You are right, Manasvi. First animals could barely see colors. They could only see light. Like something is there or something is not there. That's all. Yes, so it's like 0-1. Sir, why we see only black color? Black color is not a color. It's basically absence of light, right? It's darkness. So we don't see black color as such. Black color is basically no color present. Okay, I think that's over. We'll exhaust all our time. So the next topic of today's class is what is a solar eclipse and why do we have eclipses every year? Simple question. What is a solar eclipse? Why do we have eclipses every year? Why does sun set? Shriyan Ram is asking, why does sun set? Sun sets because Earth rotates, Shriyan Ram. I hope you know that. Earth rotates, sun is right where it is, Earth is rotating. So basically you are moving around, sun is not going anywhere. Srinivas is asking, sir, so does color blindness means absence of cone cells in our eyes? Srinivas, you're correct. So color blindness is not like you can't see any color. Usually you can't see some colors. For example, red, generally colorblind people can't see red color, right? Generally they see yellow for red or green for red. So basically the cone cells are of 3 types. I already told you, red, green and blue. Our eyes or the cone cells in our eyes are most susceptible to green color. Next, they are most susceptible to blue, and then they are least susceptible to red color. Got it? So usually the ones with color blindness usually have the defect in that red because that's anyway a weakness for our eyes. So generally those guys with color blindness can't see red, they generally see yellow or green for that. It is not absence, like I said, it is basically defective cone cells. So why rainbow have colors? I explained in the last class, Drupada Venkata. I explained in the last class. Moon covering sun is called solar eclipse. Savita Jitesh is telling moon covering sun is called solar eclipse. That's like the most lazy definition in the world for eclipse. Moon covering sun. Can we have a little more detail, guys? Can we have a little more detail, please? I will really appreciate it. Production house. Okay, we'll talk about all these fun questions. How cold moon is. Moon is extremely cold actually. Super cold and negative. But we'll talk about all this later. Mohan or Yoganand, you're a new student. Welcome to the class. Sir, which is our nearest star? Jare Atharv, you tell me. I'm not going to answer such a simple question. Okay, Shivashankar, yeah, that's what I told, right? It's because of Earth's refraction. It's a very special kind of case. It's a very special kind of case. I actually talked about it in the last class also. You can go watch the last class. I talked about it. Okay, the question is, what is a solar eclipse and why do we have eclipses every year? Okay, Saranya is telling, solar eclipse occurs when a portion of the earth is engulfed in a shadow cast by the moon, which is fully or partially blocks sunlight. Okay. And why do we have eclipses every year? Because moon covers the sun every year, right? Because that's the definition, right? Okay, I'll take all the doubts from the last topic later, guys. Let's just go ahead, na. So solar eclipse means moon covering a part and full sun. Okay, and the shadow. Okay. Someone is writing, sir. Then what is lunar eclipse? Lunar eclipse is Earth covering the moon, right? Due to revolution of Earth. Okay, a lot of answers are coming. I think you all know. I think you've all heard one definition definitely. Okay, so here is the slide, guys. Take a look at this. This is the sun. This is the orbit of the moon. This is the orbit of the earth. Can you all see? This is the earth's orbit. This is the moon's orbit. Okay, this blue circle is the moon's orbit. This is the earth's orbit. Earth is going around the sun. Earth takes 1 year to go around the sun. Moon takes how much? Moon takes 28 to 29 days. Okay, 28 to 29 days. This is approximately 1 month. Moon takes approximately 1 month to go around the earth. Earth takes approximately 1 year to go around the sun. So moon goes approximately 12 times, right? Moon goes approximately 12 times around the earth in a year. Any doubts about this? No doubts. Now you can see that the light from the sun, when it gets blocked by the moon, it basically means eclipse, right? So whoever said that moon covering the sun, their answer was not wrong. I just felt that it is not comprehensive. We need to be comprehensive when we are defining something scientific, right? When we're talking about eclipse, which is a scientific phenomena, we need to be comprehensive. So here you can see that when moon comes in front of the earth or rather, when moon comes between sun and earth, moon is able to cast a shadow. Just like when I place my hand in front of my face, I will cast a shadow on my face. Just like that, right? So now you can see there is a dark part of the shadow, which is super dark. Like, when you sit under a tube light, you always have two different kind of shadows, right? One shadow is over here, which is always darkest. The other shadow is relatively light. Now the dark shadow that you can see in the picture here is actually total eclipse. Whoever is asking me, is the topic electricity today? Electricity is the next class. I decided to take eclipse because it was remaining from the last class, and I decided to take aurora borealis because it is related to astronomy. In the next class, I'll talk about electricity. Okay. So here in the dark part we have eclipse, and here in the light part we have partial eclipse. So in the dark part we have total eclipse. What you see over here in the diagram where I've put a tick, this is total. This is total. Moon completely covers the sun, right? And whoever is standing in this dark patch sees total eclipse, and whoever is standing in the relatively lighter patch sees partial eclipse. Okay? Sees partial eclipse. Got it? This part is super clear. Yeah. Dark shadow is also called umbra and light shadow is called penumbra. This is a term that you don't need to worry too much about. Let's just stick to total eclipse and partial eclipse. This is simple English, right? It is easy. Okay. So total eclipse is when moon completely covers sun and partial eclipse is when moon partially covers the sun. So when you are in the lighter part of the shadow, you are seeing partial eclipse. When you are in the darker part of the shadow, you are seeing total eclipse. And when you are outside the shadow, let's say you are sitting here, or where I'm adding the plus, right? If you're sitting here, you are basically seeing no eclipse. Not yet. If the earth rotates, probably you will see the eclipse. Okay? Sirisha, today's topic is not electricity, I already explained. Got it? Sir, can the whole world see solar eclipse in a particular year? Savita, not necessarily. Not necessarily. Right? It usually doesn't happen. Like the eclipse might be over, right? The sun might move away before a day is complete on the earth, right? Before a day is complete on the earth. So not necessarily, not everyone in the world can see eclipse, right? Sometimes even if it is happening in their region, for example, you see in this diagram, I have shown umbra here. Let's say I live in England, or let's say I live in France or Germany. The second plus that I'm adding, number 2 plus. Here, even if there was a solar eclipse on earth, the person sitting in Germany or the person sitting in France cannot see this eclipse. So the whole world can't see solar eclipse at the same time. Only a portion of the world can see solar eclipse. I hope this part is super clear. Okay. We shouldn't eat food as it becomes poisonous. Okay, Saroj, yeah. I'll talk about all that. First, let me talk about the eclipse part. I think this is super clear. Now, the real question that I want to ask today is not this, because I know you all are super smart. You know what eclipse is. The real question I want to ask is, solar eclipse takes place when the moon comes between the sun and the earth. We are all clear about this. But the question is, then there should be 12 solar eclipses in a year. Every year, I should hear the news of at least 12 solar eclipses, because moon takes 1 month and in a year we have 12 months. Earth takes 1 year to go around the sun. So in a year, I should have 12 eclipses. Anyone has any problems with my argument? Please explain why that's not the case. Guys, if you're typing questions, I'm really sorry. I'm not looking. I'm busy explaining this funda. So it's better that you don't ask me something else. I will take doubts separately. Please answer the question I'm asking. Shravan is writing phases of the moon. Zayan is saying no, sir. Okay, Zayan, you are agreeing with my statement. Okay. Manvita is telling, sir, when sun sets, why we see sun as, we should see as it goes, right? Okay, Manvita, I'll take your doubt later, pakka. Just remind me at the end of the class. Devankita is telling, sir, because the speed of the rotation of moon and earth is different. Sir, when sun sets, why we see as sun goes down? Okay, yeah, I'll talk about that later. So can you explain? Okay, I will explain. Sir, in the last year we have, no, Dushyant, we didn't have 4 solar eclipses. That's not correct. I think we had 1 or 2. We had about three lunar eclipses last year. We didn't have 4 solar eclipses. That's not correct. We probably had 1 solar eclipse in December, or probably 2. I'm not sure. In December we had 1 solar eclipse for sure. So we had only 1 solar eclipse. I think the remaining were lunar eclipses. Because moon is closer to earth and sometimes away from it. That's fine, Harshit Patel. The question is, every month there will be one time when moon will be blocking the view of the sun from the earth, right? Every month. You can see I've drawn it clearly here. Every month there will be a moon position when the moon will block the light coming from the sun to earth. So every month I need an eclipse. Every month. Okay, Saroj is telling me they do not happen every month because the Earth's orbit around the sun is not in the same plane as the moon's orbit. You are correct, Saroj. That is the correct answer. Let me explain it to others also. But there is one interesting thing that you might not know. So let me show you that. Radhika is asking, moon's orbit is tilted. That's why. Yeah, Radhika, that's true. But let's just see how many eclipses that we can potentially have, right? So we don't have 12 because of tilt, but let's see how many we can have. Sir, how can a moon cover the large sun? Very good question, Drupada. Where were you in the parallax class? When I was talking about parallax in class number 2, science class number 2, where were you? I very, very clearly explained why the size of moon is equal to the size of sun. You should have been in that class. If you haven't attended that class, go see it on YouTube. You can see it on the app also. See it, you will understand. Kovida, sir, why didn't we take food on solar eclipse? Okay, we'll talk about that, please. Okay, usually 4 to 5. Not usually, production house. It's not a usual number. It is a high number. 4 to 5 is a high number. Okay, Venkatesh Katadi is also Radhika. Okay. It's because moon's orbit tilt that don't cast shadow on the earth. Okay, fine guys. Fine guys. Okay, so let me quickly show you. So those people who told it's the orbital tilt of the moon, your answer is correct. Your answer is correct. Now let's analyze what is really happening. Now the thing is that the first diagram that I showed you, like basically this diagram, it is not a correct depiction. It is a wrong depiction because the moon's orbit is not in the same plane as Earth's orbit with the sun. So here, if I draw a yellow line for the sun's orbit, then here blue line is the moon's orbit. Okay, the angle between this sun's orbit and moon's orbit is approximately 6 degrees. Approximately 6 degrees. Now here the angle is exaggerated. 6 degrees is not this much of an angle. 6 degrees is less angle. But the fact is that moon is also very, very far from Earth. Moon is also not this close. So just to give you an explanation, I have drawn the exaggerated angle. This angle is approximately 6 degrees. Okay. Now here, look at this picture very, very carefully, guys. Here we have the orbit of the moon around the Earth, right? And if this is the plane of sun moon orbit, then this orbit here makes an angle of 6 degrees. Now the front view, the front view you can all see, right? I just filled this orbit with a color so that you can get an idea. Okay, so sunlight is actually coming from here. That's why this is the front view, and the side view means sunlight is actually coming from here. I hope all of you are able to visualize this. Right? All of you are able to visualize this. Now the thing is that whenever moon is over here on the top, right, it cannot eclipse the Earth because the shadow of the moon will go like this, right? The shadow of the moon will go like this. It will never fall on the Earth. When the moon is here at the bottom where I'm drawing it right now, once again it can't eclipse because the shadow of the moon will go past. You can see it in the front view also. In the front view, if my moon is here, it cannot eclipse the Earth. However, if it is on the side, right? If the sunlight is coming from here, it still can't eclipse. If the sunlight is still coming from the front, its shadow will go back. It still can't eclipse. But because of the Earth's rotation around the sun, there might be a time when sunlight comes from this side. Let me explain that in the next slide. But I hope this part is completely clear, right? That the orbit of moon is 6 degree tilted as compared to the orbit of Earth with sun. And because of that, sometimes moon is too high, sometimes moon is too low to cast a shadow on Earth. Sometimes moon is also on the sides when it can't cast a shadow on Earth. But sometimes when the sunlight itself gets rotated because of the Earth's rotation around sun, we can get eclipses. So let me explain that in the next slide. Okay, so over here you can see that here is the orbit of our planet Earth. I hope all of you can clearly see this. This is the orbit, the blue line is the orbit of our planet Earth. Now you see this is the orbit of our moon, right? Here I have shown it, here also I have shown it. Okay, now moon is rotating. When sunlight is coming from the front, the view that I showed you, see this is the view I showed you, right? Let me remove some ink so that you can clearly see. Let me remove this. See, okay, this is the view I showed you. When sunlight is coming from here, there is no problem. There is no way eclipse can occur because there is no way moon's shadow can fall on Earth. So this is this situation, guys. The last slide is this situation and this situation. The one on the left and the one, this is right, and the one on the left. Okay, this is the situation that I explained on the last slide. You can see the moon can't eclipse Earth. But when Earth rotates like this and reaches here, now moon when it comes here, it can eclipse the Earth. Can you all see? When moon comes here, it can eclipse the Earth. Similarly, when the Earth is over here and when moon comes here, it can eclipse the Earth. So if I go back to the last slide, you can see that when moon comes here, I'll remove all the ink and show you again. Okay. Now, when can eclipse happen? Eclipse can happen when sunlight is actually coming from either this direction, right? Then if the moon is here, it can cast a shadow on Earth, or when the sunlight is coming from this direction. Okay, and if the moon is here, it can cast a shadow on Earth. If I see it in this view, either sunlight is coming from here and the moon is here, it can cast a shadow, Or if the sunlight is coming from here and if the moon is here, it can cast a shadow. Got it? All of you got it. So this is the condition that happens when the earth is somewhere here in its orbit. You know, this is the place. I'll remove the tick marks. Okay. See, this is the position. This is the position when eclipse can take place. This is the position when eclipse can take place. And even in this case, only when moon is from here to here somewhere and from here to here somewhere. This is when solar eclipse can take place. Okay. This is where solar eclipse can take place. Now, what is lunar eclipse? Lunar eclipse is when Earth comes between sun and the moon. Then moon gets eclipsed. This is something that happens when moon comes here. See, in the slide, it clearly says lunar eclipse. Over here also, when moon is in this particular range, right? We get lunar eclipse. Got it? So that's what is node. Forget about node. Node is the highest point, right? Node is the highest point. It's not the highest point actually. Node is the point of intersection between the sun's orbit and the moon's orbit. Just ignore this word, guys. Basically, if you want me to explain, I'll just simply explain it to you using this slide. Okay, this is a slide. The point of intersection of the two orbits. You see this point where I put red, I put an X mark and I put another X mark, right? The point of intersection of the two orbits is actually node. The point of intersection of two planes actually, where the two planes, sun plane and the moon plane intersect, the 2 points are called nodes. Let's not talk about them right now. It is a totally different concept. Don't worry about node. Okay. The idea is the remaining thing, it's completely clear. Sir, is sun also a star? Yes, Karthik Lakshman, sun is also a star. Sir, there should be only one or two solar and lunar eclipse. Avinash, that's a very good question. I was actually waiting for this question. Okay. Now the thing is that basically we have a range here, right? So what you are seeing in the diagram is one specific spot, right? But the thing is that if I show you this picture again, this is where you can get clarity. The thing is that in this slide they have drawn moon over here, which means they have drawn moon exactly over here. This is when it will eclipse the equator. This is when it will eclipse exactly the equator, but moon can also be here. It will eclipse somewhere in the north. If the moon can also be here, it will eclipse somewhere in the south, right? South of the earth. Getting my point? So basically, it might happen that in a year, when the earth is rotating, right, the different parts of the earth might get eclipsed, right? So more than twice the eclipse can take place. But generally, you will see the eclipses are quite separated. So either they'll happen together like within a month, or within 2 months, max to max, they'll have like 1-2 eclipses, and then they'll wait for 4 to 5 months, up to 6 months, and then the next round of eclipses will take place. Okay, so that's because you see, Earth has to also go about in its orbit, right? From here, Earth has to go almost halfway. So I need to have about 4 to 5 months of gap to go to the next eclipse. Got it? But in one time, I can have more than one eclipse. And I can also have eclipses in different parts of the world. So let's say one part of the world experiences eclipse. I know, like the first time. The second time, the second part of the world experiences eclipse. Got it? Sujata Sharma can't see or hear anything. Guys, am I not audible or am I not visible? I hope I'm audible and visible. Okay. I will talk about Project Srinivas. Why are you in such a hurry? I don't understand. I hope this part is clear. Yeah, it is clear. Okay, guys, let's talk about the last topic of today's class, which is Earth's magnetism and aurora borealis. After that, I'll show you the projects, and then whoever wants to go can go. And then we'll talk about doubts from the first topic, right, that we discussed today, which is the cone cells, rod cells wala topic. A lot of people were asking. And then if someone has parallax doubts, I can take that as well. Okay. And then there is some homework for you guys also. So please pay attention to that as well. Earth magnetism and aurora borealis. How many of you know that Earth has a magnetic field and Earth behaves like a bar magnet? Say yes or no in the chat. I want to know before I start talking about this topic. Sir, your video and voice is not in sync. I'm really sorry for that, Shravan. Why don't you refresh it? It might be a YouTube issue. Yes. No. Yes, no. No, yes, no. Okay. Some people don't know. You can see one Amravati doesn't know. A lot of people are okay. A lot of people, Sirisha knows, Zayan knows, Shekhar, yes. Okay, names are passing by. Prajwal, yes. Okay. A lot of you know, and some of you don't know. So let me quickly tell you what the game is. It's not a very difficult thing to understand anyway, right? It's not a very difficult thing to understand. Just a second. Okay. Let me quickly tell you what is going on. So this is your bar magnet. This is your average bar magnet. All of you know this is the bar magnet, right? This is the bar magnet. It has a north pole. Let's say I'll write an N here. I'll write an S here, right? This is the north pole. This is the south pole. Got it? Now north pole is basically attracting iron towards it. South pole is also attracting iron towards it because iron is a magnetic material. It gets attracted towards the magnet. But when we throw a lot of small iron pieces, which we also call iron filings, what we observe is that they arrange themselves in this kind of pattern, right? This is what we call magnetic field lines. If you don't know, don't worry about it. The point is a magnet has magnetic effect around it. When we throw iron filings, we can see how that effect actually looks like. Now, scientists, when they observe the planet Earth, they understand that Earth also has its own magnetic field, right? There is an instrument called magnetic compass that is used for navigation. A magnetic compass always points towards north and south directions, right? You all know about it. You have all learned it in your school, right? So magnetic compass always points about north and south directions. Why does it happen? Because Earth itself has a magnetic field of its own. Earth itself has a magnetic field of its own, and Earth behaves like a giant magnet that attracts our tiny magnetic compass ke andar ka magnet. Okay? So basically Earth, because of things that are present inside the core of the Earth. So a lot of you know we live on the Earth's crust. Then below the crust we have mantle, and below the mantle we have core. Now, core of the Earth is highly metallic. It contains a lot of iron-related compounds. Okay. Now, iron is a very important magnetic material, and there is a lot of charges and sort of ionized materials in the mantle. So, because of lot of geography happening, Earth develops its own magnetic field, just like a magnet does. Okay. This is all you need to know about this. Got it? So, Earth, guys, has its own magnetic field, right? Earth's magnet is like a giant bar magnet. Okay, Earth's magnet is like a giant bar magnet. If this is the geographical north, then this is the magnetic south. And if this is the geographical south, then this is the magnetic north. Why are we saying this? Because we humans invented this convention. When we humans started playing around with magnets, we saw that whenever we have a bar magnet, it automatically rotates in such a way that one pole points towards the north and the other pole points towards the south. So we started saying that wherever whichever side of the magnet is pointing towards the north, we are calling it north pole, and the other we are calling it south pole. So automatically north and south attract each other. So we say Earth has a giant magnet inside it, where there is a south pole where the geographical north exists and a north pole where geographical south exists. Okay? Clear? Clear. This, I hope, is supremely clear to everyone. Now understand, guys, inside the Earth, there is no giant magnet. Earth has its magnetic properties coming from its mantle and the core. You have learned about it in geography. So we are assuming that Earth has a magnet because we study its magnetic property in such a way by assuming that it has a bar magnet present inside it. Okay? Okay. Any doubts here? Why it forms only bar magnet? Manvita, it is not forming a bar magnet. It is not forming any shape actually. Earth's magnet doesn't have any shape. It is just that we are assuming it to be bar magnet because when we study the magnetic field lines of Earth, as you can see, I've drawn it here, right? In white color, you can see magnetic field lines. It is exactly like how a bar magnet behaves. So the magnetic lines of a bar magnet is very similar to the magnetic lines of the Earth. That's why we are assuming there's a bar magnet inside the Earth. There is no other reason. So why is moon having color in lunar eclipse if all the light from the moon is blocked by Earth and no light? So Madhuri, Lata, the reason is refraction from the Earth's atmosphere. You guys are asking this question a lot. So let me take it in the next class. So in the next science class, I'll explain why do we see blood moon, why do we see pink moon, blue moon, all these kind of things. And I'll also explain why do eclipses have color. Okay. I didn't understand north and south thing. See, basically, we have a bar magnet where we know that a particular pole points towards the north, the other one points towards the south. Okay, the one points towards the north, the other points towards the south. So we basically, as humans, started saying, let's imagine Earth has a giant magnet. Let's imagine, it is not real, it is imaginary. Let's imagine that Earth has a giant magnet inside it, where south pole of that giant magnet is towards the geographical north. Because only then our tiny compass magnet can have north pole on top, right? It is a convention based thing. It is not like a very difficult thing to understand. It is not a real magnet. It is not a real pole. We are basically saying, because we started calling our small tiny compass pole as north pole, we started saying that Earth has a giant south pole at exactly the same place. It is a convention that we have defined. Okay, clear? Okay, solar eclipse, food and all. Okay, yeah. So actually, I'm not very sure about the scientific reasons as to why we shouldn't do it. One reason is clearly because of ultraviolet radiation. So basically, during the eclipse, the radiations are basically coming to the planet Earth, right? Coming to the planet Earth, and we humans are not careful about it, because when sun is very, very bright, right, we generally don't look at it directly, right? So this is basically the reason for why we shouldn't look at eclipses, right? There are certain reasons as to why we shouldn't eat food and all that, but let me not talk about it, because I'm not very sure why we shouldn't do it, right? Why we shouldn't do it. So let me not talk about that, okay? Let's just go ahead and talk about aurora borealis, okay? So all of you understood that Earth has a magnetic field, right? It has a giant, we assume that it has a giant magnet present inside of it. There is a north pole, there's a south pole, which is exactly opposite to our geographical north and south. This is the idea about Earth's magnetic field. Now, what happens is that in some countries which are present in the extreme north or extreme south of our planet Earth, we see these kind of lights at night. You see these green colored light, this pink colored light. Sometimes we see other colors also, right? So these lights are on almost throughout the year. So it's almost magical, if you live in, all of you do, I know all of you live in India, but if you have any friend living in Norway, or if you ever see pictures of Norway, you can see that at night, the sky looks like this. These lights are almost always there throughout the year, but they are most visible after the summer is over. Okay, generally they are very, very faint, but other times they are very, very clearly visible. Right, they are very, very clearly visible. Okay, so these are called aurora borealis, or they are also called northern lights or southern lights. The same thing happens in southern hemisphere also, guys. It's not just for Norway. So Norway is a European country that's very close to the northern hemisphere. There is another place called Alaska. It's a part of US, and that's also very, very close to the northern hemisphere. So you see these kind of patterns. You see these kind of sky patterns in these poles, right? These northern extreme and southern extreme hemispheres, right? We see these amazing light patterns. We call them aurora borealis. We call them northern lights also. We call them southern lights also. This part is completely clear. Now the thing is, I know you haven't gone to Norway, Upender. Of course, don't worry about it. You might go in future, then you can see it. Otherwise, you can just open YouTube and see how northern lights actually look. That's an easier way, right, than actually going to Norway. Okay, because of starlight. Khaja, that's not the correct answer. Now, why do we see aurora borealis? Why do we see aurora borealis? Why do we see northern and southern lights? So this has to do something with the magnetic field of the planet Earth. So the reason I explained magnetic field for so long was because I had to explain why aurora borealis happens, right? Why aurora borealis happens. So you see, our sun is not a very calm star, right? Sun has strong nuclear fusion going all the time, which are like nuclear bombs going off inside the sun all the time. So due to that, a lot of solar material in the form of ions, solar winds, keep getting blasted out in the solar system. And all the planets have to bear the brunt of it. Now, those planets, like our planet Earth, that have a magnetic field, are able to protect themselves against the solar winds. Okay? Now, why are they able to do that? Because these solar wind particles are generally charged. So charged particles, like they are positively charged or negatively charged. If you don't know about charges, don't worry, I'll talk about it in the electricity class. But they are charged, and the magnetic field of the Earth interacts with these charges, and they are able to move it. So it's like, a magnet. So Earth is like a giant magnet, right? So the magnet inside the Earth is able to push these charged particles away. So in the diagram you can see, right, there is a magnetic shield. All of you can see this. There is a magnetic shield. So this is where the Earth's magnetic field extends outwards. Solar wind coming from here gets deflected outwards. right? So it's like a magnet repelling all these solar particles away from Earth. So it's like this wind coming, and Earth's magnetic field is like a spear that is separating out all the solar winds. Okay, separating out all the solar winds. Now, some part of the solar wind is still able to break through that shield of Earth and enter the Earth. Okay, because they are very high speed, high energy particles, they are able to enter the Earth. When they are able to enter the Earth, they are channelized by our own magnetic field back onto Earth. Are you understanding what I'm saying? These solar wind particles, some of them are high speed, they are able to enter the Earth, and once they enter, our own Earth's magnetic field channelizes them towards the poles, as you can see in this diagram. All of you can see, magnetic field is basically channelizing this solar wind towards the poles. All of you can see. Why? Because our magnetic field itself is like this, right? You can see these blue lines, right? Right? The magnetic fields are itself like this. I am drawing in red, but there are some blue lines existing on the diagram before. Now you can see that when these solar wind particles interact with the gases that are present in our atmosphere, they start glowing. They start glowing. Okay? They start glowing in all these fantastic colors. Now, technically, aurora borealis should be we in India should also be able to see it. Even on the equator in Africa, we should be able to see it. But equator pe this phenomena is not that visible, and it is also very dispersed. It's also very dispersed. But at poles, all of the charged particles are getting concentrated, right? And that's why we are able to see these bright lights in the sky in these northern and southern hemispheres. These are called aurora borealis. Okay, guys, this part is completely clear. The time is also up. Yeah. Why do you guys keep asking when the class ends? It doesn't feel very good to the teacher, when they're teaching something so passionately and students are like, sir, when the class ends? Class is ending, guys, don't worry. If you want to go, you can go. You don't need to sit. Project is coming. Okay, you can go. Okay, I think that is completely clear, right? Sir, where aurora borealis is derived? I'm not very sure. Probably it's some Latin word, I'm pretty sure. Because aurora comes from some Greek or Latin word itself. So aurora borealis must be a Latin or a Greek word. But you can check it out, Himanshi. Sir, what is the project? I'm showing, Swami, I'm showing. Sir, if we cannot see the colors when there is no light, so why we see so many colors in aurora? So, Devankita, the colors of aurora are because the solar wind particles, the charged particles, when they rub against our air, which has oxygen, nitrogen, all these kind of gases, when they rub against it, when there's friction between them, these lights are produced. This is not a scattering phenomena. This is a totally different phenomena. This is when external particles coming from the space are entering our planet Earth, interacting with the gases of our planet, rubbing and then producing these lights. Able to understand this? So that's why they have nothing to do with scattering. Okay, guys. So quickly, those who want to leave, I want you guys to take these 2 questions for the next class. Okay? I want you guys to take these 2 questions for the next class. If you guys are able to find the answer, you can also type it in the comments of this video once it is on the YouTube. You can type it in the comments, I'll read it and I'll give shout outs to those who have got the answer correct. Otherwise, I'll discuss it in the next class. The first question is, how do magnetic compass work and do they always work? So I know most of you who know about magnetic compass and Earth's magnetism already know that magnetic compass work based on Earth's magnetism. So don't type in the chat. But the real question is, do they always work? What are the cases? Where are the places where they don't work? This is where I want you to research and bring the answer in the next class. Those guys who don't know about Earth's magnetic field, don't worry. You can also Google about this. Do some research and tell me the answer in the chat in the next class or just type it in the comments for this video. The next question is the Earth's magnetic field always the same? Does it change with time? The question is, was the Earth magnetic field same 50,000 years ago, 1 lakh years ago, 10 lakhs years ago? And will it be same 1 lakh years later, right? Does it change with time or does it stay the same? Guys, don't spam. Dushyant, I will read your chat. Please just wait. So these 2 questions, I want you guys to take it in the next class. Okay? You can note it down. And then this is the project for Science Beyond Books. Okay? This is the first project that I want you guys to work on. Submission will be via Google Docs. Okay? I will generate a link and show it in the next class. The moderator will also put it in the chat. Okay? The moderator will also put it in the chat. You can just use that link to submit your project. But here, there are four things that I want you to do. The first thing is scattering of light. The one activity that I showed you in the last class, right, where I showed how milky water scatters the light. So I want you to do this experiment, take some pictures and put it in a Word file in PDF as the answer to the first project. This question I am putting as the highest marks, right? The second question, for question number 2, 3, and 4, you are supposed to write a small prose or a small paragraph explaining the answers to these questions. So the first question is, how is parallax used to measure distances? All of you understand what parallax is. I explained it in class number 2. Now you are supposed to research and tell me, how do we use it to measure distances and how is it used in astronomy? Now I don't want you guys to open Google and copy paste the first website that you see, because I will easily identify what that answer is and I will just not accept it. I want you to write anything that you personally understand. I just want to see the intent, right? I just want to see the effort that you have put. Even if your answer is wrong, I don't care, guys. Answer for question number 2 can be wrong for you. I don't mind. I just want to see the effort you are putting for that. Question number 3. What colors are our eyes most sensitive to and why? Half of the answer I already gave it in the class. It is most sensitive to green, then blue, then red. But the question is why? Some people were asking this also. So this is something I want you to go ahead and research and tell me the answer to this. And then the last question is, why are lasers generally not white in color? Has a white laser beam ever been produced? So I want you to write small prose for question number 2, 3, 4. For question number 1, I want you to do the activity, click some pictures, put it in the same sheet where you're writing the answers for the other 3, right? And keep a Word file or a PDF ready, right? And in the next class or probably the class after that, there will be a Google Docs, Google Form or Google Docs. I think either of them. Uska link we'll be generating, and you just need to submit it over there. Okay, that's how the submissions will work. Okay, so you guys can write it in a Word file, or you can write it in a Word file and convert it into a PDF, and then post it at the link that we provide. Okay. Can you make a video for the first question, Shravan? If you want, you can make a video, but then it's hard to put it in a Word file. So why don't you click pictures? I will accept pictures. Pictures is more than fine. You get that dark orangish red color, and you are pass. Use the bright colored, white colored flashlight, guys. Then you will get the real impact. And I want the blue color in the milk also. Okay, that's the end of the class. That's the end of the class, guys. Those who want to leave can leave. I'm just going to wait for 5 more minutes. Take the doubts that people had from the first topic. Those who have no doubts can leave. Otherwise, you guys can stay and ask parallax doubts also. First question, shall I write step-by-step activity also? Production house, that is not needed. For the first question, step-by-step activity is not needed because I have already explained that activity in the class. So you can just say, this is your outcome, right? This is your output. You show me initial setup. You show me some middle setup as you are adding the milk. Adding the milk by spoon or dropper or anything you want, and show me the final setup where you get the colors. You can show me 5 pictures also at multiple different stages. I'm totally fine. Okay, Ajitesh is very happy. I don't know why is he really doing that? Sir, I don't have torch. You can buy it, Himanji. It's very cheap. You can also order it on Amazon. Don't worry about it. You can get it. Comedy class. Okay. I am happy that you had fun. Sir, can't understand first one. Which one, Manvita? Can you please tell me? Okay, the first one, matlab are you talking about this one? I think you're talking about this one, right? So this one is Purkinje effect. I think that's what you're talking about, right? So quickly in 1 minute, I'll explain it to you again. Can you please tell me, is this what you are asking? Are you asking about Purkinje effect or Purkinje effect? Okay, you can use your cell phone torch, Himanshi. I have no issues. Manvita, can you quickly tell me, are you asking about this or not? Sir, how to fill the assignment? Type it in a Word file. And submit, or you can convert it into a PDF and submit. Please show me project questions. Vora Tabassum, you can watch it. Okay, quickly I'll show you. Take a snapshot, Vora. These are the project questions. First question in the project. Manvita, I think you didn't attend the last class. Okay. Why don't you see class number 3 of Science Beyond Books Junior? It is on the YouTube and it's also in the app. You will understand what I'm talking about. So in the last class, I talked about scattering of light, right? I talked about scattering of light. And from there, I'm actually getting this question. So you can watch that video and then you will get an idea. Sir, I didn't understand the third one. So basically, whoever is asking me about third one, Varsha Lal, the thing is that I talked about this in today's class, right? We have some cells that are sensitive to brightness, some cells that are sensitive to color. Now the thing is, the cone cells, which are sensitive to color, are able to see red, green and blue colors, RGB, just like our screen pixels. Now what I want you to research on is what are the colors that our eyes are sensitive to, which I've already given you the answer, RGB. But why are they sensitive to this, and why is it most sensitive to a certain color and less to the other? You can also search about color blindness, and that will also give you clarity about question number 3. Okay, I think that's it, guys. Let's end the class. I'm very happy you all turned up. See you tomorrow in the maths class. Bye bye.